Today we will solve some more quotient rule examples using derivatives. So, as we all know, we have the power rule, which tells us the derivative of x power n is n x n minus 1. And you know the product rule is whenever we have u times v, our derivative will be u prime v plus v prime u. Now for the quotient rule is whenever we have a fraction. So we have a numerator and a denominator. We take the numerator to be u and denominator to be v. We write u is and what v is, and we find u prime and v prime. The final answer and the final derivative of our function will be u prime v minus v prime u all over v squared. We will go from simple examples to more difficult ones. Let's start with the first one. F of x is x over x minus 1. As we said, we take the numerator to be u and the denominator to be v. So our u is x, our v is x minus 1. The derivative of x is 1, and the derivative of x minus 1, x becomes 1 and negative 1 becomes 0. And now we just apply u prime v minus v prime u over v squared. So u prime into v minus v prime into u all over v squared. And we can distribute the numerator to simplify stuff further. So 1 multiplied by x is 1, 1 multiplied by negative 1 is negative 1, negative 1 multiplied by x is negative x, and in the denominator we have x minus 1 squared. The x and negative x will cancel out, we'll be left with negative 1 over x minus 1 all squared. Let's do another example. Let's say we had, for instance, f of x is x squared minus 4x over x minus 3. As we said earlier, we take the numerator to be u and the denominator to be v. And you solve u is, v is, u prime is, and v prime is. So our u is x squared minus 4x and our v is x minus 3. Now we need to find u prime. The derivative of x squared is 2x. And the derivative of negative 4x is negative 4. Now the derivative of x minus 3, derivative of x is 1, derivative of negative 3 is 0. And now we perform u prime v minus v prime u over v squared. So we'll have 2x minus 4 into v, which is x minus 3, minus v prime times u all over v squared. Now we can expand the numerator if you want. So we multiply 2x by x, we'll have 2x squared. 2x by negative 3 will have negative 6x. Negative 4 multiplied by x, negative 4x. And negative 4 multiplied by negative 3 is positive 12. Minus x squared and plus 4x. All over x minus 3 all squared. Now, we can combine like terms. So 2x squared and negative x squared will be left with x squared. Negative 6x and negative 4x and positive 4x. Negative 4x and positive 4x cancel out, so we'll be left with minus 6x plus 12 all over x minus 3 squared. That is our second example. Let's do a third one. G of x is 3x squared plus 2x over x squared plus 1. As we said, the numerator is u, denominator is v, and we use u prime v minus v prime u all over v squared. So our u is 3x squared plus 2x. Our v is x squared plus 1. The derivative of u here is 6x plus 2, and the derivative of v here is 2x. And now we apply u prime multiplied by v minus v prime multiplied by u all over v squared. We can distribute the numerator if you want. So we'll have 6x multiplied by x squared is 6x cubed. 6x multiplied by 1 is 6x. 2 multiplied by x squared is 2x squared, and 2 multiplied by 1 is 2. Minus negative 2x multiplied by 3x squared is negative 6x cubed, and negative 2x multiplied by positive 2x is negative 4x, all over x squared plus 1 all squared. Now we can combine like terms. 6x cubed and negative 6x cubed cancel out. Negative will be left with 2x squared, and positive 6x and negative 4x will have negative 2x and plus 2 all over x squared plus 1 all squared. Now let's try involving something with a radical and something where we'll have the product rule and the quotient rule at the same time. So let's start first with the radical. As we said, our final outcome will be u prime v minus v prime u over v squared. U is our numerator and v is our denominator as always. So u is radical x minus 5 and v is x squared minus 1. Now, the derivative of radical x is 1 over 2 radical x. How did we get that? Radical x means x power half. The derivative of x power half means we take the power down to the power x half minus 1, which will become half x power negative half. And we know that a to the negative m equal to 1 over a m, so that the powers become positive. We'll have 1 over 2 x power half. And you know that radical a means a to the half. We can move either way, from radical to power or from power to radical. Here we'll be moving from power to radical, which will give us 1 over 2 radical x. So our u prime will be 1 over 2 radical x, minus 5 will become 0, and now v prime is 2x. And now we do u prime v minus v prime u all over v squared. Let's do one with a product rule in it. F of x is x squared plus 2 vx minus 1 over x plus 3. Now, as we said, we take the numerator to be u and the denominator to be v. So u is x squared plus 2 times 3x minus 1. We take all of the numerator as u, and v is x plus 3. Now we'll need to find u prime. To be able to find u prime, we'll need to apply the product rule here. The product rule says whenever we have two stuff multiplied by each other, u and v, we perform u prime v plus v prime u. So we take this to be u and this to be v. And we'll have u is x squared plus 2. V is 3x minus 1. Derivative of u will be 2x, and the derivative of b will be 3. And now u prime v plus v prime u. So we'll have 2x into 3x minus 1 plus 3 into x squared plus 2. So we distribute now the 2x multiplied by 3x will be 6x squared. 2x multiplied by negative 1 is negative 2x. 3 multiplied by x squared is 3x squared. And 3 multiplied by 2 is 6. Combining like terms, we'll get 9x squared minus 2x plus 6. This is our u prime. And this is our u. And this is our v. We need to still get our v prime. Derivative of v prime is simply 1. Derivative of x is 1 and derivative of 3 is 0. And now we perform u prime v. So u prime times v minus our v prime times u all over our v squared, x plus 3 whole squared.